Hi guys, and welcome to another lesson. In this lesson we are going to talk about how to interact with users and getting data in and out of Python. Basic input and output of data is a major requirement of any programming language, and we need to consider how our programs will interact with users and with data stored in files. To send data to users via the stdout, we use the print function, which we have used several times now. And we learn how to control the output more precisely here. To read data from users, we use the input function, which prompts the user for input and then returns a string of raw characters from stdin, standard input. The print function is more complex than it first appears, in that it has several optional parameters. And its simplest level, you simply pass a string and print, displays it on standard output, followed by an end-of-line character. The next level of complexity involves passing non-string data that print then converts to a string using the str type function before displaying the result. And stepping up a gear, we can pass multiple items at once to print, and it will convert and display them in turn, separated by a space. So there are three fixed elements in print's behavior. It displays the output on stdout. It terminates with an end-of-line character. It separates items with a space. In fact, none of these are really fixed, and print enables us to modify any or all of them using optional parameters. We can change the output by specifying a file argument. The separator is defined by the sep argument, as you can see in the example below. And the terminating character is defined by the end argument. The following line on this example prints the infamous hello world message, specified as two strings, to a file using a hyphen separator and the string end as an end marker. So the content of the file should be hello-world end in capital. And then we have a string format method that really comes into its own when combined with print. This combination is capable of presenting our data neatly and clearly separated. In addition, using format can often be more efficient than trying to print a long list of objects and string fragments. There are many examples of how to use format in the Python documentation, so check it out. We can also communicate with the user using the input function that reads values typed by the user in response to a given on-screen prompt. And it is our responsibility to convert the return character to whatever data type it is represented and handle any errors resulting from that conversion. And one thing to note is that in Python version 2, the raw_input function was used instead of input, like in Python 3. The version 2 input function behaved rather differently. It evaluated whatever the user typed. This created a security issue because malicious code could be input. The version 2 input of Python 2, the version of Python 2 input function was removed in version 3, and raw input was renamed to input. So let's create a small script of a guessing game where we ask the user to enter a number. If the number is too high or too low, it prints a warning. This could form the core of a guessing game. So if you want to experiment with it more, you can. So let's just try to create a new file. I'll explain a little bit later. Oops. Very angry program. This is a very basic guess game that normally is given to as a school assignment. Let's save the file and run it. Try again with a higher number. And let's try it with the correct one. Perfect. So this is a very simple guess game. It would be cooler to take a random integer between 0 and 100 and then try it and create a loop. It just kept on going while the number is found. So you can play around with it. So here the user is provided with a prompt to enter an integer in the appropriate range. The value read is then converted to an integer using int function. If the conversion fails, a value error exception is raised and the error message is then displayed. If the conversion succeeds, we can break out of the while loop and proceed to test it against the target, confident that we have a valid integer. So let's just try once again to so it gives us an value error exception. So that was a very simple game. And next section I want to talk about is using text files. Text files are the workhorses of programming when it comes to saving data, and Python supports several functions for dealing with text files. One note is that the file interface in Python is really a specialization of a higher level abstract interface, starting with a class called io.iobase. We can mostly ignore these. They simply create a standardized set of operations that applies to text files and other file-like objects. And we saw from earlier presentation the open function used in previous sections, and it takes a file name and a mode as arguments. The mode can be any of R, W, RW, and A for read, write, and append respectively. Some other modes are less often used. There are also a few optional parameters that control how the data is interpreted. So please see the documentation for details. The R mode requires the file to exist. The W and RW modes create a new empty file or overwrite any existing file of the same name. The A mode opens an existing file or creates a new empty file if a file of the specified file name does not already exist. The file object returned is also a context manager and can be used in a with block, as we saw in the context manager section. If a with block is not used, we should explicitly close the file using the close method when we are finished with it, thus ensuring that any data sitting in the memory buffers is sent to the physical file on disk. The with construct calls close automatically, which is one of the advantages of using the context manager approach. Once we have an open file object, we can use the readlines, or readline as required. Read reads the entire file contents as a single string complete with embedded new line characters. Readlines reads line by line into a list, and the new line character are retained. Readline reads the next line in the file, again retaining the new line. The file object is an iterable, so you can use it directly in a for loop without the need for any of the read methods. The recommended pattern for reading the lines in a file is shown here. We can write to a writable file object using the write or write lines methods, which are the equivalents to the similarly named read methods. But there is no write line method for writing a single line. So if we are using the RW mode, we might want to move to a specific position in the file to overwrite the existing data. We can find our current position in the file using the tell method. We can go to a specific position, possibly one we recorded with tell, using the seek method. Seek method has several modes of calculating position. The default is simply the offset from the start of the file. So now we have all the basic skills to write working Python programs. However, to tackle larger projects, which are the focus of this course, we want to extend Python's capabilities. So in the next section, we are going to start to explore how we can use that with functions. So see you in the next section.